Welkom aan iedereen op het ARinfuse training seminar. I will continue in English because a lot of our partners don't speak Dutch. So it's easier if I continue in English. Welcome to the ARinfuse training seminar. I'm going to share my screen now because I have only a few slides to show you. And those are slides with the program. I am Katleen Miserez from the Flanders Environment Agency, and we are hosting this ARinfuse event. ARinfuse is a project that we are working on. It's an Erasmus Plus project, and it's all about infusing skills and exploiting the potential of augmented reality within the utilities network sector. That is very briefly what the project is about. It's one sentence. But luckily, we have Konstantinos Smagas from GeoImaging with us. And he is a project leader, and he will tell us more about the project. After that, Narek from DFKI will talk to us about current trends in applied research regarding augmented reality. Östman from Novogit, he will tell us more about the ARinfuse curriculum and the use cases. And then Dries Luts, my colleague, he will tell us some experiences with augmented reality in the utility sector. And I want to thank the people from Aquafin for sharing their experiences with us. There will be the possibility to ask questions, so you can unmute yourself and ask a question, or you can type your question in the chat. We'll then have a little break, and after the break, we will be putting the theory into practice. So within the project, we have developed a lot of learning material, and that's all available on a training platform. And Roderic from GISIG, he is going to introduce this training platform to us. There is a lot of material on the training platform, and we will go through 2 lectures a bit more in detail. So Anders will be guiding us through putting augmented reality in operation, and Apostolos will talk about the visualization of underground utility networks. And then finally, we will conclude with a live demo of the ARinfuse tool. It's an open source software tool that is available on the platform that you can download and install. And then you can use it to play around with real data and real images. And Elena and Narek will show us how we can do it. You'll have again the possibility to ask questions, and we will try and answer all of your questions. And then I'll come back to you with some concluding remarks and the official launch of the platform. So I now give the floor to Kostas to tell us what the ARinfuse project is all about.
Thank you, Katleen. You should be able to did I activate my camera or not? Yeah, sure. Okay, desktop. Can you see my desktop now?
Yes, we see your presentation.
Great. Welcome, everybody. My name is Konstantinos Smagas, Kostas, a very typical Greek name. I'm coming here on behalf of GeoImaging Ltd, which is the Cypriot partner leading this project. I would like to welcome you on this training seminar and multiplier event. And I would like to thank Katleen and Dries and all the people in VMM that did a wonderful job to have this seminar today. We were supposed to have a live stream, even a live stream. However, due to some technical details, we were not able to complete the link. However, here we are through Teams, and we are really excited to present you our project, and for the first time to deliver the training material to the community, to the audience. We are still also trying to tune up and tweak the training material. So feel free to explore the platform. You will be receiving the login information after the session, and we appreciate your feedback. So whatever you want to share something with us, please feel free to do so. And before we start, I think most of us, we are through our home offices, and it's a pity that we cannot see each other and interact. However, I would like you, if it is possible, to run a small exercise with me. I want you to grab your smartphone, and we should start sharing our experiences. It's just a brief session. You can scan it, and it will direct you into the Slido, which is our event here. Can you see my screen now?
Yes.
Yes, we see it.
Okay, great. Feel free to join. And for your mobile phone, you will be able to duplicate the screen what you're having here. And the first question that I would like to share with you and to start figuring out what is where do we stand when it comes to augmented reality and different geospatial technologies is how important do you think is the adoption of augmented reality and geospatial technologies for utilities management? Do you think it's really important, very important? Is it important? It's moderately important, slightly important, or unimportant? I thought to have this question so we can start to establish a first basis with our audience and to figure out what are the expectations and how do we view ourselves where we work and to adopt this kind of technologies. So definitely with the 14 answers so far, we can see that there is a lot of expectation when it comes to getting these kind of technologies. I'm very positively surprised, I might say. So 50% of the respondents until now think that it's important. 25% is very important, and 25% is moderately important. This is a good sign. This is a good sign. It means that maybe we're not fully convinced by the technologies themselves. However, we do recognize the need that we should move forward and start using these kind of tools. So people are still voting. That's really great. So if you would like to cast your vote right now, do it, because I'm gonna move to the next poll. 47% important. So we have more than almost 70% that is accumulated answers that is important and very important. The second question. Oh wow. Okay. So the second question is, how about you? Does your organization use tools such as augmented reality to perform day-to-day operations? Do you use it? Do you use them extensively, moderately, not at all, or you don't happen to know? You have no idea. Okay. Okay, so this is very close to what to our instinct as well. I mean, to what we perceive. We have gathered through asking around and our stakeholders. Not at all. It's 81%. So there is definitely a gap there, also in the market and also from an operations perspective. Some of the people in the audience do use this kind of technologies, or augmented reality itself, or something similar, I guess. And yes, this is also a very, very good clue. So most of the people in the call around us have not been exposed to this kind of technologies. This is indeed an indication. And then I would like to move to the third question, which is demands a bit more of effort from your side. You really have to type. You can type just one word or a phrase. What do you think is the biggest challenge when it comes to adopting innovative technologies such as augmented reality for underground grid management? So, what do you think from a personal perspective or from an organization perspective? It's the biggest challenge. Well, okay, it's difficult. Data availability, I understand. The maturity of technology, data accuracy, well, that's a problem we faced quite some times when we devised the software. For qualitative data, okay, that's an interesting point. We should definitely have an idea later on. I'm really, coming from the social sciences, I'm really keen on launching qualitative analysis for a lot of things. So the maturity of technology is getting pace, definitely. And the data accuracy, well, this is indeed something, yes. Exactly. Yes. I would agree. I would agree with most of the answers here. Method of displaying, somebody said, which means that the interfaces are not nice or okay. Up-to-date data. GPS reception, well, we have Galileo now, and maybe this could improve things. But good. We have an idea that people around us are, I mean, in the audience are definitely concerned about certain issues. Those are the gaps. Those are the challenges that when we are devising a training material, we should have in mind. Thank you very much for participating in this small exercise. I think it was great. We will consider that as part of the feedback we gather for the training material, and at least it's some kind of interaction since we cannot be together. Okay, so coming back to the presentation. After the Slido exercise we ran, we understood each other a bit more now, I guess, and here we are. It's the ARinfuse workshop that we are trying to tackle some of the challenges that we saw before. The event here is part of a series of 5 events that are going to run that will wishing to attract almost 200 participants. This is the 4th dissemination event and the first training event, and we still have to go with the one in Cyprus. And we ran the same events more or less in Sweden last September, almost a year ago. That was a great event indeed, through this nice old castle. Anders was very a great host, and we even launched a nice demonstration of a mock-up of the material. We did the same in Italy. You can see Giorgio here with presenting the project. And of course in Kaiserslautern in Germany, which is the home office, the headquarters of DFKI, who are developing the documentations for us. So what is the ARinfuse? What is the project about? It's an Erasmus project, Erasmus Plus project that is ending in November. We took a small extension due to the COVID pandemic, so we'll be running until February. So have in mind that we're going to be with you to support you during the training. anytime you gonna wish, definitely until February, and why not after that. The total grant is close to 300,000. Not enough. It's never enough, but we definitely try to do our best. Everything is funded by EVEP, which is the LLP agency in Cyprus. And our project is a small niche because if you go to the Erasmus platform and you try to figure out how many other projects are doing more or less the same, it's from the 1,074 projects, only 27 are dealing with augmented reality, 7 with maps. Only 2 of them have the utilities management keyword in their description, and only 1 is dealing with underground grid. So in terms of content, we are definitely trying to cover a gap there, and we are addressed to a niche market, let's say. We are a well-organized, well-comprised consortium. It's GISIG from Italy, it's GeoImaging, who is leading the project from Cyprus, Novogit from Sweden, DFKI from Germany. The Cyprus University of Technology is the second biggest university in Cyprus, and the Flanders Environmental Agency, and of course is the Suez Board of Nicosia, part of the stakeholders. They own the grid, and their input has been very valuable for us to devise the material. So who is our audience? We are targeting students on higher education institutions, but mostly professionals such as engineers, technicians, and managers that are dealing with the underground infrastructure. And we are delivering tailor-made e-learning modules. This is done through the Moodle platform. It's a free-to-use, free-to-register platform. We have devised really nice material for our audience. The access is for free. You can use it for your in-house training. You can use it for your lectures. Just get there, try to navigate a bit, and we're going to be there for you to provide you some advice. And of course, it's not only static PDFs or presentations. We just push it a little further. We are providing software. It's a demo software, try to emulate the feeling of setting up an augmented realities application and to augment, retrieve the GIS data and augment images, and of course data sets that you're welcome to freely play around with them. So how did we come up with the idea? The idea came through the Lara project. It's an Horizon project that my company was involved. We devised an application doing exactly that. You are navigating through the space, and you're trying to augment the underground grid. That was a very challenging project. We came very close to bringing to the market. We are still trying, of course. The challenges that you also mentioned are there for us. The data availability is a huge challenge, and the training of the personnel, the accuracy of the data, and this all created the idea on us that. Yeah, maybe we should prepare the ground for the community to start accepting this kind of devices. We have received an award for this project, and I would like to share with you the video. I don't know if we have the time, but yeah, I don't know if you hear the sound.
I think there's time to share the video.
Okay. Do you get this nice composition? Yeah, so this is the Lara device that kicked off the idea for this project. This is the user interface. Something very similar we are using for the ARinfuse one. Okay. If you want to learn more about Lara, you can visit the project. However, this gives you a small idea on the fact that the people involved also in this project and designing the materials have been were engaged into an actual development project trying to do exactly that, to deliver a device that gets signal from the satellites and augments the underground grid with certain success. But yeah, here we are. But ARinfuse is not just Lara, it's a combination of other projects. It's the GeoSmart City project, the GISIG, the Elena project, also by our technological partners. So together with Lara, they are putting a lot of valuable input into that when it comes to geographic information systems or operations management, and of course, the consortium itself is a strength, since we have the VMM here with us. That's an umbrella organization managing and operating utility networks and has a lot of connections with stakeholders. And thank you once again, Katleen and Dries, for bringing this thing together. The CUT, the university, is employing professors and lecturers that are devising scientific material that are being handed to the community. And of course, SBN, which is a grid operated with permanent staff. And this gives us access to the grid, that we can go there and work with it and test our tools. This is how we did it. We mapped the process, realizing that there is a gap when it comes to training for adopting these kind of technologies. We devised the curriculum, the tools, the training framework, and the demo cases. We used real data from the cities, from Genova, from Aalst, from Nicosia in Cyprus. And then we divide the training events to start spreading the word. And what we're trying to achieve is to increase the competitiveness and the employability of the people involved in the sector. This is the priority of the Commission, and we are trying to achieve some impact in this direction. So what do we deliver in the end? After the end of the session, you will be able to go into the Moodle platform and start browsing the different modules. We are trying to cover the entire spectrum of the technologies involved, including the augmented reality and geospatial technologies, photogrammetry as well, and background knowledge about utility networks. So the idea was that you can start learning about how to have a holistic approach towards grid management. And you can discuss it with your department, with your colleagues, with your friends, with your university students, and somehow have a complete overview of the sector. And why not devising a business plan to start pitching to your CEO or to the bank, and in order to start investing on these technologies. We try to cover even that. Anders has a very interesting presentation later on that can guide you through the process. It's not only presentations, it's also software and data. It's a pity right now we cannot perform you a live demonstration with augmenting some pictures, or could take you out in the field and we could view on how this works. But yeah, I understand that a lot of you have already been exposed to this kind of technologies, but a lot of you have not. And together with software, it's the data that you can play around and you can use it freely. It's demonstration data, but they correspond to the reality for specific areas in selected cities. So how are we delivering that? It's through the Moodle platform. This is accessible through the platform itself or through our website. So you can log into the ARinfuse.eu and you can start the process there. We are going to launch it through specific training events. This is the first one. So this is the first event we are launching the platform. It's supposed to have a duration of 5 days. This means that for the next 5 days and until October the 1st, we're going to be there for you. So if you have any questions, you can just contact us through email or any way you wish. Within the platform, you can use, after the presentations, there are the contact details of the authors. You can directly be addressed to them, or you can have if you want a general information, you can send it to the email of the project. And together with the training, we have the multiplier events. Right now, this is the fourth one that we are running, and still there is one to go in Cyprus around December. This event also marks the start of the training period. We are trying to figure out how this will evolve. We are really excited to kick off the process. This will be done through our website, of course, and through the Moodle platform. However, if and for some reason some of you would like to move forward with that, we will be more than glad to discuss the prospect of providing in-house training or some small seminars if the pandemic allows us at a later point. That would be terrific. Well, that would be all from our side, and you can follow us on Twitter, and you can log into our website to obtain more information. And we really do appreciate your feedback. Try to contact with us. We will try to include you and bring you on board if it's possible within the ARinfuse project. And why not in the future we could also collaborate from a more partner position. Thank you very much, Katleen. I think we should proceed now with the next speaker.
Yes, thank you, Kostas. I think we can now move over to Narek, who will show us the current trends in applied research on augmented reality. Narek, I give the floor to you.
Thank you, Katleen. I would like to welcome everyone to our ARinfuse online seminar. I'm Narek. I work in German Research Center for Artificial Intelligence in the field of computer vision. And today I'm going to talk to you about augmented reality in general and its trends and how the research is going nowadays. So let's start without further ado. What's augmented reality? It's simply put, when we put the reality, the real world, and then the virtual world together, and we overlay them together, then we will have augmented reality, such as is in this example. We have a map of an urban area, and then we have a virtual model of the object of the buildings, and then we overlay them together, and then we have a 3D view that is overlaid on the real map. And all right, but what do we do? What do we expect from augmented reality in industry? What are we hoping to achieve? Well, we are looking forward to increase the efficiency of our workers and have them make less errors in their work, and also help them by transferring the knowledge of the experts to the people who are new in the field. Like, for example, in the example, we can see that we can help the person who is trying to repair the part of the car by showing them the different steps that is necessary for the repairman. But that said, for augmented reality, what do we need for augmented reality for it to work in general? Well, technically, we need a capturing device, a device like a camera. And then we need the display device to show our virtual elements on it. What's also very important is our virtual content. So someone needs to take care of creating that kind of contents, and usually experts should be in charge of that. And then something that is usually hidden and people don't see is a tracker. What's a tracker? Well, we do need to know where our camera is in the real world, so that we can have the correct views of our virtual objects that overlay on the real world. And the process that is happening there, sort of hidden, it's pose estimation. So what do we get out of pose estimation? So we need two types of information. It's the intrinsic parameters and the extrinsic parameters of our camera. So that, what does that mean? The intrinsic parameters is usually referred to the field of view and then the image center, basically. And the extrinsics refers to where a camera is located in the real world. So that is the position of the camera and then the rotation of the camera relative to some sort of object. Then there, all this information is presented in a matrix form, and famously is known as the model view projection matrix. With that said, this is kind of the base principle for augmented reality and for the trackers. But on what kind of devices can we run this? So the ideal device for an augmented reality is goggles or some glasses, if you like to think about it. The research on that started very, very early in the early 60s. And nowadays we have devices such as HoloLens. And for the future, there's already research going on about lenses that can be implemented on the eye. But those are not the only devices that we can run augmented reality on. What exists nowadays is also tablets. All of us, more or less, have tablets. We have smartphones. And this creates a unique opportunity, because then we can launch augmented reality applications for like wider range of audience. So we don't need all of us to go and buy a HoloLens to be able to use augmented reality. It's just here, it's just in our hand. And this also creates a nice opportunity for content creators. Why? Because nowadays we have some open source, some not, tools for creating augmented reality applications, such as Vuforia, AR Core, and or AR Kit, basically. Moving forward, how did it all start? Like, when did augmented reality become a thing, basically? The history of augmented reality starts pretty early, actually, in 60s, where Sutherland was able to show a 3D model on this strange device that you can see on the left on his head. And it wasn't until 90s where Azuma defined what augmented reality is in his paper. So he introduced it as a technology that combines the virtual world and the real world. And it's interactive in real time and is always in 3D. If a system has all these three elements together, then we can claim that now we have an augmented reality application. Well, if we can see that this technology is not actually new, but we can just see nowadays that all right, some sort of practical applications are out there. But how do we know? How do we understand where we are nowadays? I would like to, for example, introduce you to Gartner. Gartner it's an information technology and advisory company which helps other companies to find technologies and if they can adopt it to their business model or not. So in 2004, Gartner released Hype Cycle, saying that augmented reality is already sort of new. It's not very well heard of. People don't know what's going on, and based on their chart, they claim that for more than it takes more than 10 years for augmented reality to step into the production phase and be something useful. So what happens usually is this kind of technologies that appear, first the name appears and then people have high expectations out of it. Oh, I don't know, it's going to do sci-fi stuff. But that's not usually the case. Then the expectations get more realistic. And then people start, well, maybe this wasn't what we thought it would be. But that's not actually a bad thing, because now in 2008, the Gartner Hype Cycle shows that augmented reality is getting close to a level where we can now have very practical applications out of it. So in 5 to 10 years, we're definitely going to see much more practical applications of augmented reality. But what about now? What exists now these days? What's happening in research centers? Well, it's always good to have a look at the history. The first phase started like in early 2000s, where there were marker trackers. People developed like this sort of fiducial markers. They were like basically shapes like circles or squares. It was a specific pattern where the cameras can detect and track them, and then put some sort of augmentations on top of them. And this was usually happening with webcams and big PCs, and of course they were all very difficult to carry around. So it wasn't really practical. It was just the early research on augmented reality. What happens is these markers transformed into markerless trackers, and then the devices got also better. Then we had smartphones and tablets and more computation power as well. So now we have, now we were able to track the device itself without adding any kind of marker on top of it, without cluttering the scene. And nowadays we have SLAM systems, simultaneous localization and mapping. They just don't need anything. They don't need a marker. They don't need an object. They are capable of mapping the environment, create a mesh out of it, and are already implemented in devices such as HoloLens. And pretty accurate as well. So this creates a very unique opportunity for augmented reality applications, because now we can combine different things. We can combine model trackers with SLAM systems and have meaningful applications on top of it. But then where are we going from here? What are we expecting to see in the future? In which aspects of our life is augmented reality going to be useful? Well, in many aspects, from dating life to driving to workers that are in utility network, utility management, repairs. It is going to influence many aspects of our life, but what is necessary for this? Well, should we like all have different type of devices that do different type of augmented reality? Well, no, because that's actually a ridiculous idea. We are not going to be able to buy 10 type of devices for different purposes. So we are looking forward to something named like cognitive augmented reality. But what does this actually mean? What kind of characteristics should this augmented reality have in the future? We now have different type of devices, but which one is good? Which ones more practical? Well, we are working towards a solution that we would like to have a device that is accessible everywhere. So maybe just one glass, maybe even this type of lens that we talked about, that is going to be implemented in our eye, or we can just wear it like normally, like a normal visual optical lens. And this kind of AR, this kind of cognitive AR needs to be able to understand several things. It needs to understand the environment we're in. It needs to understand our gestures. It needs to understand our needs to be able to adapt to be able to adapt to the person that is wearing it, and shows them the information that they are really interested in. Also creates the opportunity for them to explore different options. But this is sort of the road for the future. Nowadays, what do we have? So there was definitely there was Project Lara. Kostas talked about it. That was that this project for localization, for finding the position, Galileo was used, and then the information of the infrastructure was visualized. Very nice idea. But another concept that has happened, that appeared recently, was the concept of augmented things. So what's the idea behind augmented things? The idea was, okay, now we have several devices. These devices are in different categories. One is in industry, the other one is a coffee machine, the other one is a printer, the other one is, I don't know, a toy the child is playing with. How do we use augmented reality for these purposes? So the idea was to create a universal app, and have this app sort of interact with our objects without needing a big database or any database at all. So the idea is to, if a manufacturer is creating a device, they would implement some sort of chip inside it. And this chip is containing all the data necessary for visualization, for the 3D models and so. And our device is simply going to connect to this, our device is going to connect to the tracker and then exchange the information, even maybe update it in real time. This definitely solves the problem of connectivity. So there is no need for an internet connection there, because now we can use several other protocols like Bluetooth, for example, to carry out the communication. To show you some examples is, like, imagine we have some sort of industrial device, and we would like to know the information about it, and then we have a tablet. So what happens is simply our tablet is connecting to the chip implemented in the device, and then we see our augmentations. Of course, this is not yet fully implemented, but the idea is moving towards that. And another example would be simply a sewing machine, like this use case that can happen at home, basically. Where is this going? This basically shows the different categories in which we have the application for augmented reality. So industry, simple office, breakfast at home, toys, maybe even history. And this is why this sort of a universal application is needed, and it's a good thing to have one app that can do everything. Another concept is to have our rooms, basically the I don't know, workplace, living room, wherever we can be, to have them already, the model already created and ready. This makes tracking a much more simpler, because now our device is capable of tracking wherever we are, and then we can add contents on top of where we are. This usually happens to make our tracking much more accurate we have something called sensor fusion, which combines different type of sensors together to get a more accurate result of tracking. So in this case, we are combining cameras with inertial sensors. And what happens is we have a better, more robust tracking system, less prone to errors, and our devices that in the future may also use this idea to create a better tracking device and have the augmented reality on top of it. Other example would be in maintenance. This is also pretty relevant to transferring our knowledge from one expert to another, or from one expert to a beginner when they start a job. Like imagine we have some sort of a training session for the beginners where the expert wants to teach them how to do things, but well, okay, in real life, everyone gathers around the expert and then it shows some of the steps. But with AR, we can simply make this more interactive for the beginners and more intuitive for the teacher to transfer its knowledge to the new people. So here, for example, it shows that we have like some sort of electrical device. We have some sort of problems. The AR app tells us is somehow connected to the device, shows the problems, whether it is fixed or not, and gives us feedback. The other example would be, for example, in also repairs, where we have to use our hands basically. So what about then? What if things get more complicated? Well, they may look complicated, but we are nowadays also capable of utilizing machine learning and deep learning to understand hand gestures and basically recognize actions. So in this scenario, we have just some user who's working with some device, and now someone else. What if someone else wants to replicate it? How do we know that if they are doing the right action, if they are carrying out the right action? So what we do is we have a video sequence, and imagine like lots of them for training purposes for machine learning. What we do is we have a recording, and then we have action recognition and then hand recognition. We add the additional contents on top of that to make it easier for the user to understand what they're doing. And then at the final product is some sort of assistance system that helps the user with the tasks that they are carrying out. So this is the same video that has happened, that was shown before, and now we have a new person trying to do the same procedure. So what we see is the action and the hand gestures being recognized, and is shown to the user how it should be. So if it's like if it's like incorrect, it turns more into a red. If it's more in the correct area, they can see it in green, basically, with additional data such as the arrows overlaid to give the user more information. With this, I would like to conclude my presentation. And thank you, everyone, for listening. Katleen, back to you.
Thank you, Narek, for this very interesting presentation. We should move over now to Anders, and he will tell you what we did within the ARinfuse project, where we developed the curriculum and business cases. So, Anders, I give the floor to you.
Yes, what I'm aiming to talk about is going a little bit from the research laboratory to our training and learning material. So what I will talk about is in this first session here is about how we have designed the curriculum and also some of the business cases that we have been working on, which is one of the foundation of the courses that we have developed. So as you know, the project aiming to develop and test learning material within the augmented reality technology for the water and wastewater sector. And we are addressing higher education as well as vocational or professional training. Kostas also mentioned that all learning material is available on open license, that's Creative Commons. That means that you can use it freely, it's open, and in case you modify it, what you have to consider is then to pay proper references to the creator of the material. But you are free to modify it and, for instance, to translate it to other languages or make it better. And the approach we have followed when designing the curriculum, that is the set of courses, that we started by looking at the core business profiles, core business processes, and to see what are the potential use cases for using AR in water and sewage companies. And we also looked at the professional profiles. That means what type of professionals will be addressed by such changes in the operations. And as a result of this, we ended up in a number of different process diagrams, which we have partly been using also in the learning material. Anyway, based on these process descriptions and process, we have analyzed them and specified the required knowledge and skills. In order to carry out these new operations, what should an employee be able to do? What knowledge and skills are required? So that's what we analyzed, and the result of this was then a set of courses which we call the ARinfuse curriculum. So I will now first just go through some of the business processes or potential usage of AR technology within the water wastewater sector. And the first one, which usually comes to one's mind, is that we need to repair pipes, water pipes or sewage pipes, and they are hidden underground, and we don't want to cut other utility networks and make damage on them. So we need to visualize what is the position of the pipes underground and also other utility networks. This is, of course, one of the probably most commonly used applications. Another topic which also we'll had a look at was equipment maintenance. That means that if you wish to do maintenance on equipment, in this case pump station, then you may need guidance on what type of maintenance you have to do. And also that some of these stations are located quite far away from the city center, and so there might be non-educated persons that are doing other activities in these stations and may need some additional assistance as compared to regular personnel. I'm thinking of, for instance, guards, watchmen that are checking that all doors are locked, that they can also do some maintenance when visiting the site. Also listening to Narek's presentations, there are several cases for augmented things here, but this is nothing that we have so far been working on in the learning material. A third scenario or third use cases is the increased use of sensor networks or sensors in the water and sewage sector. In this case, we are looking at noise sensors that are that the water network is being equipped with, and by using cross correlation of signals, we can determine where is the position along the pipe of a certain leakage, because the leakage creates noise. And this is just a third example. And we have also looked at additional examples, AR processes, for instance, house connection locations, planning and design of new assets and plans, the procurement procedure, plant management, etc., etc. So in total, 10 different processes we have analyzed, and these are being the foundation of the course curriculum that we have developed. And also, these are also potential usages or application areas for new AR applications. But our focus is on the curriculum and the training. So the curriculum, we have been focusing on training courses for professionals. That means that they are 1 to 2 days each. They are based on e-learning. So you can study it on distance and go through the material. As I mentioned, it's open material based on Creative Commons. We had a problem with suitable software, but when we have good software available, we have turned also the courses into practical oriented. When suitable software is lacking, the learning material is more principle oriented. This learning material can also be used within the university courses, and we have University of Cyprus here that is also using the material for the academic courses. Our new courses that we have developed are grouped into 3 different categories. One is the principle of AR technologies, where we talk about methods and device calibration and so on and so on. So I will urge you to go there and have a look at the material. And the third topic is, or sorry, the second topic is AR for utility networks. This is more directed on how to use AR technology within with the main focus on water and wastewater sector. So we have 3 different courses here also. And then we also have developed the software for supporting the learning activities. And this software is available, and we also have learning material related to this software. For instance, documentation, how to set up the systems, the software, and also how to create exercises and also finalize the exercises. In addition to this, we also have existing course material. There is a fair amount of learning material available on different open learning platforms. So we have included them in our portfolio. These courses are not developed by this consortium. It has other origins, but there are courses also on underground infrastructure, drainage and sewage, water supply systems, indoor positioning, etc., etc. And then for universities, I don't know if we have any universities or academics present in the audience, but what we have been working with is to adapt some of the university courses to open e-learning and for e-learning for professionals. So to summarize this, what I talked about are first some of the business cases that we have been using for as a base for specifying the required skills and knowledge that we expect of the workforce in the future. And we have adapted the learning material and designed it according to these expected requirements. Then I briefly talked about the courses and the new courses, and also that we have some existing courses that are broadening the scope of the learning activities. I hope you have by this received an understanding of the content of the curriculum and the way how we have created it. And the important thing is that the curriculum is based on what we perceive as the most important business processes in the near future. Thank you for listening.
Thank you, Anders. I now give the floor to Dries Luts, and he is going to tell you something about real experiences with using augmented reality in the utility sector. Dries, I give the floor to you.
So normally a representative from a utility company, a sewer utility company in Flanders, Aquafin, would be giving this presentation. But it's because the ongoing COVID-19 situation, they aren't able to make the time free to come and give this presentation. But we're very lucky that they were able to provide us with some information about their experiences with augmented reality. So within Flanders, augmented reality in the utility sector mostly seems to be in an exploration phase. People are looking at for which use cases they can use augmented reality, and they are performing some limited tests with some of the augmented reality tools and looking at what is the maturity level of several of those tools. Some of the more extensive tests that have been done by Aquafin is the use of augmented reality for remote assistance. The goal here is to allow technicians at office to better support workers in the field. Field workers are provided with augmented reality goggles that allow them to share information in real time between the office and the field. So technicians at office can directly see what the field workers see in the field and can provide immediate feedback to the field worker using, for example, augmented reality pointers. Aquafin is mostly looking at remote assistance because they want to use it to help in addressing a problem that they have of having a group of highly skilled and experienced field technicians that are becoming a bit older. They aren't yet nearing retirement age, but they are going to need to transition from the physical demanding field work to less physical demanding work in an office setting. And at the same time, Aquafin also encounters a problem where they have difficulty in finding new high-skilled technicians to replace the technicians that will transition to an office setting. The new trainees often do not have the required skill and education level to be effective from the get-go. To address this experience and education gap, Aquafin is looking at whether they can use augmented reality remote assistance to allow the field technicians that have transitioned to an office job to allow them to give an opportunity to give immediate feedback to the new field workers, and also allow for learning opportunities for the field workers in the field without needing to pull away the older technicians away from their new duties at the office. So during the testing phase, Aquafin also encountered some practical problems that I wanted to share with us. One of the problems that I encountered was the fact that the communication between the field and the office is still an issue. For example, the augmented reality devices that I have tested, especially the goggles that I tested, didn't have any hardware support for 4G. This meant that they had to provide their workers with mobile 4G routers to allow them to connect to the office using the augmented reality device. And they also encountered that, well, we would expect Flanders, because it's a very densely populated region, to have a full 4G coverage. This is not actually the case. At least the coverage is not sufficient to allow for good communication that can be operationally used with the office. For further testing, they are looking into whether they can augment the workers' cars with larger Wi-Fi and 4G antennas to hopefully alleviate the coverage problem. Aquafin also pointed out that there are some safety risks with using augmented reality devices. For example, an important risk is that the workers tend to get a reduced spatial awareness when they are using augmented reality devices. For example, with the goggles, the field of view of people using the augmented reality goggles is smaller than if they wouldn't use the goggles. And sometimes people get focus too much on the augmentations in their view, and they get a bit of tunnel vision and forget to look around for tripping hazards, for example. Another problem that I also encountered was that people, when they are using the augmented reality device and want to get an overview for the infrastructure they're looking at, they tend to want to take a step back instead of just removing the augmented reality device and directly looking at the infrastructure they're looking at and getting that way an overview. This means that people are unintended pointed at taking actions that may put themselves in danger in the confined spaces they are expected to work in. Another issue they also encountered was that some of the augmented reality devices that are currently available are difficult to clean. And this is a problem, certainly in these times, when augmented reality devices need to be shared between multiple persons. Aquafin also pointed out that it's really important to take into account the human factor when you design your implementation strategy for augmented reality. For example, during testing, they ran into a problem that some of their participants in the test regularly forgot to charge the augmented reality device, or when they did charge the devices, they, for example, forgot to take the batteries from the charger when they started with their day job, and they were in the fields without a charge device, so they couldn't use the augmented reality tools that they were provided with. A select number of the people that participated in the test also treated the augmented reality devices more as a gimmick. And as soon as they started with performing some tasks that were related with their day job, not related to the testing of the augmented reality device, they just locked away the device in their car and stopped using it. So in general, the picture both at Aquafin, but I think also at other utility companies in Flanders seems to be that the augmented reality ecosystems that they have tested aren't mature enough yet for the operational use cases for which they want to use the devices. One of the issues I run into is that the source data isn't there yet, isn't yet ready for operational use of augmented reality devices. For example, data isn't yet detailed enough. Data coverage is also often insufficient. Another issue is that hardware, that a lot of the augmented reality hardware, while a lot of work has already been done, still seems to be more of a prototype than a real operational device. An issue they ran into was that the setup procedure for augmented reality devices can be really complicated. And the image quality when used outdoors of some of the augmented reality devices was also really insufficient, making it infeasible at the moment for operational use. They did acknowledge that augmented reality is really easy to use on smartphones and tablets. However, due to the operational environments in which they want to use the augmented reality devices, which are really confined spaces and tasks for which the work needs both of its hands free, it wasn't feasible to use devices like smartphones and tablets. Aquafin also pointed out that the technical knowledge that is required at the moment to be able to operate augmented reality devices, unfortunately, has little overlap with the existing technical knowledge of their field technicians. And they are also ran into difficulties in finding good educational resources to be able to train their workers on how to use augmented reality devices. However, they did indicate that there are a lot of promising developments that are probably working towards bringing up, improving the maturity of augmented reality ecosystems. For an example, they mentioned the fact that new augmented reality devices become a lot more ruggedized. So in Flanders, augmented reality definitely has potential for the future. For example, the remote assistance use case that has been tested by Aquafin in the field is considered by them to be definitely a valid use case. They know of another Flemish company that doesn't work in the utility sector, but also in the technology sector, and that works with that has overseas international offices, and they use augmented reality remote assistance for long distance support, and they are able to use the technology operational because they are able to forego some of the problems that there are with using the devices in Flanders in the field, due to the devices being mostly used indoors in a cleaner environment where there is good access to the internet. Furthermore, there are also developments in building information management that are really promising, and that could be really valuable sources for good data that could allow for effective operational use of augmented reality devices. And furthermore, Aquafin also hopes that improved technology awareness with new incoming employees could improve their uptake. Mostly improved technology awareness because also on the consumer side, augmented reality applications become a lot more common. So thank you for your attention.
So the second part is putting the theory into practice. And first of all, I'm going to give the floor to Roderic Molina. He will introduce us to the ARinfuse training platform. Roderic, I give the floor to you.
Thank you, Katleen, and good afternoon, everyone. I will now share my screen. Okay. So the idea is to provide to you a quite short presentation, basically on what is about with the training platform, and basically how to access the material that we host in this training platform. And let me remind you, as Katleen said before, that you will receive after this seminar a mail with all the details on how to access, so don't worry, because there will be, of course, the link to the platform and most important, your credentials to access the Moodle system. So what I want to make now, it's just a quick tour on the platform itself, just for you to know how to access the materials. But for those of you that are already familiar with the Moodle system, it will be definitely very easy to access the material. First thing is that you can access it from the website of the project or directly to the Moodle platform. I would advise you to go first to the website of the project, so you can check the project website, and there's the specific section there devoted to the training offer. From this section, you can see that there's a list of available modules, and that is divided by topics. Okay, so you can find also a link to go directly to the platform, or you can go to a login or even create an account if you don't have it. But as I said, you have already an account that has been created, so you will receive this afternoon just some instructions on how to access. Just put your password. Your password will be asked to be changed, so you choose the one of your choice, and that's all, you're in. Okay, as I said, what we can do now is to take a look to the platform. As I see here, as I said, you have a list of all the modules are divided by topics, and well, it's just the first look. What is important is to go to the platform itself, and from here we can start talking about how to interact with the system. This is a Moodle platform, as I said. And first thing I want to say is that what you have here in the homepage, it's a link to a feedback form. Okay, this is a link to a questionnaire that we encourage you to fill in, so we can have some feedback from you about the module itself, the materials, but also about the platform, the usability, and things like that. It would be very important for us in this first phase because the platform went public yesterday, and the materials are quite fresh there, let me say. And we would like to know from you what you think about the materials, even if you find some errors or some problems on accessing the materials. It would be perfect to know it from you. Okay. What you have also, and it's very important, it's a link to our mail. You have it also here. During the first days, that will be better explained by Katleen, but you need to know that whatever question you have regarding the materials itself, meaning the content, but also about the functioning of the platform, you should contact us. We are here to respond to every question you may have regarding the materials and the platform itself. Okay, let's see now how to access the modules. What you have here is a list of all the available training modules and a direct link to access them. Okay. Let's start by going to one of these modules, the first one. It's just to illustrate how to browse the training materials. Since you are new on the platform, first thing the system will ask, of course, it's for a login information. As I said, you will receive this afternoon these credentials. And just put it and proceed. First thing you will see here, it's some description of the module itself, just to be sure about you choose the right materials. And before entering, I mean, this is the page where you have some information on the module, what we call the metadata, and where you can subscribe yourself to the model. Okay. Of course, you can also change the language of the platform, so you can see everything in the language of your choice. For example, in English. Okay. So you have the enrolled page. The enrolled page have at the end a button to auto-enroll yourself in the course. Once you enroll yourself in the course, an automatic email will be sent to you, giving you a welcome to the course, and then you can access the page of the course itself. Okay. Okay, now you can read an abstract, for example, of the course, and you can also access the full description we saw before of the training course, and most important, you can access the training material. Okay, we can say that most of the materials in this training platform are based on HTML5 presentations. Some of them are presentation with just slides. Others have notes, for example, and we have even presentations with audio, with voice on them. Okay. In the page for each of these presentations, you will have different options. Of course, you will have the possibility to go to browse, to go with the slides. Okay. And the slides will be presented, and if there is notes on the slides, it will be presented there. Okay, you can directly go to some other slides by going here directly. So there's basically a player to navigate through the presentation. This specific presentation have notes. Remember it. This is important to know for you that for each of the HTML5 presentations, you have also possibility to see it in full screen, okay, by going with this specific button here. And this is something you may like also for each of the presentations in this training platform, and there are a lot of them. You have also the option to see it as a PDF, okay. A PDF will be ready here for you to download it or see it when you want, offline if you want. And in this case, being a presentation with notes, you have here a view of the PDF together with the notes also. And this is basically one example, but it's all the presentations on the platform are more or less based on the same schema. We have also, of course, other formats in the platform. Let me just give you an example. For example, in the training course related to the documentation of the ARinfuse tool that will be presented afterwards, you can here access the page of this specific module that is consisting on basically documentation. So in this case, it's a PDF that's open here in the platform that you can download, but you can see it from here. This specific module also contains some other types of material, like these videos, for example. These videos are related to the functioning of the tool, and can be opened by here. Okay. So we have for this specific module this kind of formats, and we can also, for example, take a look to another course, this one from Anders, for example, that have other kind of formats. The schema is always the same. You have a presentation of the module, you can see the full description, and then comes the learning path that organizes the different types of materials. In this case, what we have here, it's also an HTML5 presentation, but with the particularity of having voice on them.
Hello, everybody, and welcome to this module on putting AR in operation.
Okay, this was Anders, you already know him. And as the other presentations, we have also the option to see it in full screen in another window. Very important to download the PowerPoint. And if I'm not wrong, for this specific training module, there is some other formats that may be of your interest. For example, we have some files that can be downloaded to support, for example, in this case, this exercise. And at the end, if I'm not wrong, yes, there's a self-test. You will find a few of them in the training materials. Self-tests are basically some questions, some multiple or simple choice units that you may find on the training material. At the end, of course, this is self. You will receive your score at the end of this exercise. Okay, so finally, not much to say. It's very easy to browse the modules and to access the training materials. Again, I would advise you to contact us in case of any problem regarding the platform, if you cannot access some materials or there's some problem, or then just give us your feedback on the materials. And this is basically how the platform works. And if you have some question, of course, you can say it here. And if not, Katleen, that would be all from my side.
Okay, thank you, Roderic. I can hear myself. I think you need to mute. Yeah, okay, thank you. So thank you, Roderic, for giving us this introduction to the training platform. You showed us a few of the modules. And now Anders, he's going to give us an insight in one of these modules that Roderic just showed us. So Anders, I give the floor to you for putting AR in operation.
Thank you very much, Katleen. I'm trying to connect here now. You should see my screen now, I hope.
Yes, we see it.
Yeah, great. Okay, hello once more. And now I will give a short introduction or a short summary of the module on putting AR in operation. And Roderic already showed you some of the functionalities of it. But this module or this course is based on the assumption here that if we assume we are interested in introducing AR technologies in our organization, what are the proper preparations to do? And in this course, we are focusing on 3 different questions that we are trying to answer. First one is, what is the value proposition, or why do we really want to use or introduce AR technologies? Secondly, the required investments and what are the expected costs and benefits with such an implementation. And thirdly, also, which processes and personnel categories will be affected. That is, of course, also important when preparing different parts of the organization for the implementation. And during this course, there are some information gathering that we have to do. And the 3 most important ones are perhaps that we need to collect experience of others. That is Dries earlier mentioned some of the experiences that they have experienced, and of course other documented experiences are valuable when in order to answer the question or how to introduce AR technologies. The vendors are important players, so what solutions do currently exist at the vendor side? And then also we have key performance indicators. How is our operations really working out today? Where do we have bottlenecks, or what can we improve? And the content of this course is consists of 6 lectures. And as Roderic showed, it's streamed PowerPoints with the voice. There's one exercise that's dealing with the cost-benefit analysis, so you can play around with it more. Then there's also a self-test. And we are giving links also to supplementary material where you can read more. And the expected workload of this module is 11 hours. So the first to start with is the initial study of our implementation. And here we focus on what are the expected added values, and what type of technical solution do we propose, and what are the organizational impacts. So these are 3 very basic questions that we address. And for the value proposition, we are working on the business model canvas. Perhaps some of you are familiar with that one, but it's a framework for how to specify a business model. And one part of this canvas or business model canvas is the value proposition. So here we have to analyze what value will the AR technology provide for the organization. And there can be, in principle, 2 different types of values. One is the value for the customer, for the client. And second value is it's not adding value to the client or to the customer, but is anyway necessary or improving the efficiency and effectiveness of our own operations. In this case, we are working on the use case that was I described earlier before the coffee break, related to there's a leakage occurring, and we have to intervene and do some digging in the ground, and then we need to avoid cutting off other utility pipes or utility networks in the neighborhood. So the value added for the customer, as an example, is that we assume that since we are more sure about where the position of external pipelines are located, we can dig faster and do the repair work faster. So that means a reduced repairing time and less interruption in supply of water. So that's a value for the clients. And we'll come back to this within a few minutes. Also based on our previous work that I was talking about before the coffee break, we have developed the process diagrams, who is doing what, starting from that there's an incoming telephone call, that there is a break in the network, for instance, water supply network, and there's a leakage, and the alarm goes to the network manager, and then there's a GIS support team who prepare data, and then there's a repair team and network operators who is going to fix the leakage. So what we do here is that we model this process at the high level, not at the detail level, and then we look at which processes will be affected if we introduce AR technology. And in our case here, it's that the GIS support team who are preparing the data will be affected, and also the network operators, the repairing crew. They have to mount the AR equipment, and they have also to repair the leakage. The second part of the course is related to cost-benefit analysis, and here we are looking at investments and also some key characteristics of the cost and benefits, for instance, return of investments and break-even points. And the result of such analysis is usually expressed like a cost-benefit analysis graph like this one, where in blue we have the accumulated benefits through the years, up to a period of 10 years from here. And then in red, we have the accumulated costs. So this graph is that in this specific example, is that we'll have a break-even point after 1.5 years. And if we have a 10-year as a where we are analysis, our CBA analysis, we have a return of investments for 625%. That means our benefits are roughly 6 times higher than the costs. I must directly say also that you should not take copy this graph straight away, because it's based on several assumptions, and they are clearly demonstrated in the learning material, and you can play around with the figures and assign other cost-benefit models if you wish. But the basics of this cost-benefit analysis is that we have identified the processes being affected. We have to collect KPI, key performance indicators. We have to create benefits and cost models. And then also, we are basing our analysis on Excel. So it's quite easy to do also uncertainty analysis where we change the parameters. I mentioned, for instance, that we are assuming that the leakages will be repaired faster. In this example, it was assumed a 15 minutes reduction of repair time. And if you think that's too optimistic, you can change it to 5 minutes or 2 minutes or whatever. And you can see the effects of your CBA graphs right away. The next phase, I will not talk so much about it, but it's about the designing new processes. Here we are proposing to use something called business process patterns. That are, a pattern is a concept in computer science where you are reusing good designs which are working, and unfortunately we don't have up to date so many process patterns in AR technology, but we have for some other fields that are related here, for instance the customer support service, etc. The final part which we will cover in this course or in this module is the pilot testing. That is that when we have made our CBA and see that, well, it might be interesting to do some investments, then we need to verify that our assumptions are correct, will we actually be repairing the water pipes 15 minutes faster as an average? And also we have to verify that the new processes we have specified, that they are operational, and also suggested for improvements. And some guidance on how to design such pilot tests are treated in one of the lectures. So in general, what we have is this proposed process flow, that we start with the initial study and then do the cost-benefit analysis, then go further on with design of new processes. We test them, and then we have to do the implementation. But we, in this module or in this course, we do not treat the implementation issues at all, because it's very depending on the organizational context. For instance, about the personnel training and how to install new software and hardware, etc. It's very much depending on the organization we are addressing. So that's in general the course on putting AR into operations, and I hope you are interested in it and you will visit it, and you can please send comments or questions to me. Perhaps someone of you have questions right away.
Anders, is the IT market ready to deliver AR programmers?
AR
Programmers.
Programmers, okay, software engineers. Yes, many universities at the academic level have courses on the components for software engineering, and so I would say at the high level, yes, we have master and bachelor students that are able to develop and implement AR applications. However, there is in general a shortage of computer scientists. So that means it's not that easy to get hold of such skilled personnel. If we go to the vet part, that is the professional trainings at the lower level, that's they are to my knowledge not usually addressing this type of computer science and computer vision. So but for at the bachelor and master level, I would say it's a fairly good supply of software engineers. That's my impression from the Swedish perspective.
Okay, thank you, Anders, for your answer. And we will now give the floor to someone from the academic world. Apostolos, I give the floor to you.
Thank you, Katleen. Let me turn my camera on and I will share you my screen. Okay, can you see my screen?
Yes, we can see it.
Okay, I will present you a newly created material for the cartographic visualization from 2D to AR for the underground utility. Okay, this module has two objectives. The first objective, the main objective, is to provide a clear definition of what is the cartographic representation and to provide the basic rules to the learners to follow for the creation of an effective visualization, of an effective representation. And the second part of this module, the second course, will introduce the learners to the potential application of the 3D geovisualization through VR and AR. This course is created for participants that they have a prior knowledge of geoinformation, such as students or professionals. In the course Basic Principles of Cartographic Representation, participants will learn the basic cartographic theory for making optical design decisions, for making visualizations for their data. So this course is starting with an introduction to the basic principles of visual communication. After that, the measurement of level of geodata is presenting, and then the use of visual variables. And finally, what is the effective type of map design to create, and the classification of geographic data. As for the strategies to design the best possible map layouts for different types of cartographic outputs, there are plenty of information are given in this course in order the students to learn to have the knowledge to create the most effective type of map design for their data. And also they will have a knowledge in order to solve practical problems when creating maps. In the first part of this course, we're presenting the basics of map design, including how the map makers customize their map to fit to a specific audience, medium, and purpose. Also, we introduce some topics, including visual variables, scale, and online map distribution. In the second part, which is named Lettering and Layout, we're focusing on how to place labels and marginal map elements, such as scale bars, north arrows, etc., and discussing all the rules of typography and the art of text-based elements. Then, at the end, we are focusing in this part and another important topic in cartography, which is the design of map layout. In the third part, we'll learn the tools and the rules to the students on how to conceptualize and visualize and communicate at different phenomena, and how to create choropleth maths, proportional symbol maths, and another different kind of cartographic representations. And finally, in the fourth part, we're discussing the ways that we can use the ways we can standardize our data in order to consider the spatial dimensions of our data and of the geographic phenomena that we are going to map. The outcomes and the goals and outcomes of this lesson is to provide to students to be able to select and combine all the appropriate visual variables to represent in the best and the most efficient way in order to communicate the map content with the map audience, to apply principles of color and contrast. They will be able to discuss the current trends in cartographic science and technology, and they will be able to demonstrate mastery in map creation for analyze, critique, and share high-quality maps. Some training material I will present you some training material. This is a training material for the retinal variables, the variables that you can use in order to take a visual order in the categories of the data that we want to represent. This is from the semiology of graphics. Another training material for typography, different components of type design, the factors that influence the font style, also the label placement in maps. All these are very critical parts of map creation, very critical knowledge in order to create the most effective visualizations. Also, the color, which is the most critical variable when making maps, and the training material for mapping techniques. This is a core block math. This is a bivariate proportional symbol map. So at the end of the first course, the students will be able to think and to create maps that they can represent different phenomena with using with the best way the visual variables. As for the second part of the course, of the module, the 3D cartographic visualization strategies, in this course, the students will learn techniques on how to visualize geographic data in 3D and in order to identify patterns that they are not clearly visible in the 3D depiction. So this course will introduce the students in the types of the data that they can have and how to use in order to create 3D visualizations. And with the final result to be a visualization without to reduce the number of dimensions that we need in order to create an efficient map. So as for the parts of this course, there are 4 parts. In the first part, we explore in depth, in detail, the 3D visualization, starting from the main factors that they affect the 3D views, such as perspective, vertical exaggeration, etc. And we're providing information and knowledge for the 3D visualization of surfaces. In the second part, we are presenting all the basics on how to create and visualize 3D data, also introducing on some topics that cover in depth the 3 dimensions of GIS data. Part 3, 3D cartographic techniques. In this part, the most common cartographic techniques that are used for the 3D depiction of photorealistic and cartographic scenes will be presented, is presented, and will also cover the challenges and advances in geographic visualization when creating 3D visualization. And finally, in the fourth part, we are presenting some basics of the 3D viewing environments in AR and VR, and also introducing some topics that cover more in depth the visualization approaches that making underground infrastructure accessible. So as for the goals and outcomes of this newly developed material, after the successful completion of this course, the students will be able to argue for the need of 3D graphic representation, to describe and to know what are the key difference between 2D and 3D mapping, to have a clear idea what is different between the kinds of thematic representation and 3D dimensional maps, explain different perception in the 3D visualization, understand the basic requirements for the 3D viewing environment, and also perform techniques to visualize all the needed GIS information in 3D. So some training material. This is how we can visualize surfaces on 3D, how GIS data can be transformed into embedded holograms and to visualize underground features. Also, as underground features can be a special case for a geospatial 3D modeling. Thus, we are presenting to them the ways that can illustrate this kind of information. Yes. Also, the symbology of subsurface utility network, which is very, very critical for them to know how to use the different symbols in order to create the most efficient maps. And also, we are provided them some perspective views on how they can merge this information and how they create and illustrate 3D information for underground pipe utilities. Finally, we have a questionnaire. In this questionnaire, after the end of the material, after the end of the 2 courses, the student will check the knowledge gained from these lessons. And the question is divided in 4 parts. Each part has each part examines the most key information and information presented in these 2 courses in order to see how in order to see the level of the knowledge that gain each student of this course. That's for me. Thank you.
Okay, thank you, Apostolos, for giving us an insight on the material that's available on the training platform. I think we can now go to Elena and Narek to give a demonstration of how the ARinfuse tool works. So Elena, Narek, I give the floor to you.
Okay, hello from my side. I'm Elena Valari. Just a moment to share my screen and open the camera. Okay, I think that now you can see my screen. So as I said, I'm Elena Valari. I'm software engineer and I'm working for GeoImaging. And now I will present the 2D view GIS part of the ARinfuse tool. Basically, the ARinfuse tool supports 2 different modes, the training mode. As you can see here, in the training mode, you can have access to the 2D view GIS part of the software. You can click here and you can see the main screen of the GIS viewer. For the purposes of this demo, you are using the GIS data which are provided by our partner VMM. And as you can see here, we have a lot of utilities network. We managed to integrate all of them in cooperation with VMM and the other authorities. Here we will present the main feature of the GIS module. However, you can check and download freely the ARinfuse application from our website. And of course, you can also check the documentation, as the other guy said, which is available on the Moodle platform, along with some sample data to play around. So now we can proceed to the presentation of the software itself. So as you can see here in the right side, there is the main menu, the main functionalities of the GIS. More or less, it's a typical GIS viewer. So here is some tools, and from the other side, you can see the layers which are already displayed on the map. We can just play with the layers. We can change the style of the layer. You can also delete a layer if you want, of course. You can also add the layer just clicking this button. It's very easy. You can load whatever you want. And one more feature that I would like to show you, which is usually very useful for the guys they are using GIS, is the feature that the user can access the features of the attributes of each layer. So, for example, you can just select one of the layers here, or you can also open a zip file from your disk. But let's select one of them to see what is available here. There's a small menu. So by the get feature, you see all the attributes of the table. In addition, you can just make a count of the feature. You can just get the geometry only of the data. And if you go back here in the main screen, you can also apply some queries, let's say, to the data. And here, for example, you can filter in order to get only the data with some specific threshold. For example, sorry for the typos. For example, you can just get only the pipes with diameter larger than 0.9. And as you can see here, the data is updated. And that's it from this part. In addition, the GIS part supports a spatial database system. It's an optional part, but I will say a few things about it. So the user can use this feature in order to save his data in the database. And by using this feature, the user is able to search about the data which already inserted in the database. Here you have access to the data of the table. Of course, you can immediately make any changes if you want, and the changes will be stored in the database immediately, and that's it. And I will conclude with the most important, let's say, in terms of interconnection between the 2D part and the 3D part, which is the clipping window method that we are using. That is the button, let's say, the feature. So what is this? The user can use some of these tools to identify an area of interest. And let's assume that this is an area of interest. So the user can use this button in order to clip the area. And the export of this is an XML file. And why we need this XML file? I will show you an example just to show you the form. So what is it? It is an XML file where all the features which are included in the same file are transformed in a form that can be easily accessed from an AR tool. Sorry for the delay, but it's a lot of data here. But the key point is that the connection between the 2D and 3D part is made with this XML file. That's it from my side. And I think that now I can give the floor to Narek to continue with the 3D part of the tool. And of course, if you have any questions, let me know, write me. That's it.
Thank you very much, Elena. Just a second. Okay, so basically, I would like to encourage you to download our tool and look at the tool documentations and try it for yourself. But let's continue the story from where Elena left it. So this information that is outputted via the 2D view, they are basically name tags of our infrastructures in XML. So they contain information about the position of the pipes, of the sewer manholes, and so on and so forth. This is technically a lot of overhead if we want to use it in an AR application. So what we did was we developed a preprocessor which simplifies that XML data and it just keeps the ones that are necessary for visualization. So at the end, that cluttered data looks compact like the one that I'm showing you here. So for this, the user only needs to go to the trainer and just click on the XML processor. This will create a compact file from the part from the clipped part that Elena just showed. Moving forward, this is going to have some drawbacks to my presentation earlier, which was when I was talking about pose estimation. In case of ARinfuse, we have still images, and the goal here is to just show the processes that is needed for augmented reality, but in real life, it has to be like a live video feed. So what we do is camera calibration. And what does it mean? We are trying to estimate our intrinsic parameters, which is the field of view and the image center, basically. Have in mind that calibration is a process that should happen only once, and afterwards it is saved. Usually, like, the best way to do camera calibration is with checkerboard patterns, but in our case it was difficult because our data was coming from many different areas, so it was kind of a little bit unpractical to ask the people who are capturing the data to perform this and then, you know, change the settings and then perform again. So it's going to be difficult. So we decided to somehow put the calibration on the side of the user. And the method that we've used here is called the vanishing points method. So what's the idea? There's a lot of math behind it, but to make it simple for the user only needs to find a pair of orthogonal parallel lines. So that means lines that are parallel in reality. They are not parallel in the perspective. So, for example, in our case, it's going to be, as an example, from here to here, and from here to here. And any of these poles, for example, so they are going to be orthogonal to the other set. And then afterwards, what we do is we press the button C, and then the application creates our intrinsic parameters. Unfortunately, there is no direct way to know if these values are good or bad, because they are going to be used in our next phase, which is the pose estimation. So what we do is now we have the feature points. We need feature points for pose estimation. And here it is these cones that the positions are now recorded in GNSS. What we do is we know the order in which the positions are recorded. They are like saved in a file, and we click on them in order. So 1, 2, 3, 4. And then we look at the result of the pose estimation. So the idea is the clicked points are green, and the red points uses the information from the previous part, which is the camera calibration, to do a reprojection of the points. So the closer the red points are to the green points, that means our calibration was good or not good. So in our case, we see that, oh, okay, it's kind of acceptable. The reprojection error, that's what we call it, it's not that large. So this is something workable. So we save this, and then we move forward to the training part, where we are going to use all the information from the previous part, which is the XML, the 3D, the XML data, the calibration data, and then the pose estimation to create the virtual overlay. We have made this with Unity because it's pretty easy to make visualizations. And at the end, our 3D scene is going to fill with augmentations that is being read by the XML part. And what we do is then we create a camera that is looking at this as a background image, and then is looking at the scene with the virtual objects. So this was a small demo from our part. I would like to give the floor back to Katleen. Thank you very much for listening.
Thank you very much, Elena and Narek, for this demo. We all encourage you to download the tool and to try and use it. And if you have any questions, don't hesitate to ask them. In fact, we have a little time now to answer any questions you have at this moment. So if anybody wants to ask something, please go ahead. There is a question. Does the learning platform contains, it's difficult to read. Does the learning platform contains a few examples that illustrate?
Does the learning platform, maybe it's a question for Roderic. Hi, by the way. It's a long time we've met, Roderic. So does the learning platform contains a few examples that illustrate the value of the augmented reality but then in an operational context, maybe just to convince the non-believers? That would be interesting.
Yeah, I definitely think that there are some materials related to concrete examples on the usage of augmented reality technologies actually there's a whole topic devoted to this argument. I'm pretty sure in any case that the authors can respond better than me on how these concrete examples are illustrated on the models. Right now, I don't remember exactly, but we can check. Kostas, maybe you can help me on that. If I'm not wrong, there was this module from Anders, of course, but there are also some modules regarding the usage of, and there are some experience related to concrete use of technologies like that in the utilities sector.
Yes, if I get the question right now there is an example by Anders. The Excel file is there. You can play around with it. The hypothesis is based on our broader experience. However, every single organization has different needs. And the best thing is, of course, to go around with your colleagues and discuss the actual costs, the return on investment perspective, interest rates, everything, and inflation rates. Everything is can be modified and everything can be entered into the file. But that's a good point. Maybe we. I don't know, Anders, do we include a scenario based on a real case? Because I think at the moment we do not have a real case, but we could use the Lara project one. We have a detailed business plan about that. Maybe we could retrieve some information from there. It has been conducted.
In any case, yeah, if I may add, we can say that both the modules from spatial data to augmented reality and visualization of underground utility networks in augmented reality are mainly based on that context. So basically, these two modules give the potential user in the utilities sector all the clues on how to prepare data for the visualization and usage in a augmented reality environment. Also, if I remember well, in the module of Anders, there's a specific relevance of that specific sector. But in any case, what you have in that topic, these two modules I refer to, give to the potential user in the utilities sector all the clues on how to prepare data for this kind of environment. This without mention that we have two specific modules that are devoted to the usage of our tool that make use of this data for augmented reality environment.
Anders here, referring to the module or the cost-benefit analysis that I think Kostas was thinking of. It is based on a real case. However, it has been modified a little bit and some assumption made because not all key performance indicator were available. But the case is based on the situation in City of Stockholm. but nevertheless, there are some assumptions that are a little bit tweaked, so it's not a pure real case.
Okay, thank you. Somebody else has a question? If not, I will conclude with, well, it has already been mentioned, this was the first training event that we did. So we can now officially launch the training platform. And after this event, I will send you all an email with credentials, so you will all have a username and password to access the training platform. In the mail I will send you, there will also be a link to an evaluation form. I kindly ask you to fill it in so that we can get feedback on this event. Once you can access the training platform, Kostas already mentioned it, the first 5 working days, the experts will be available for you to answer your questions very, very quickly. But of course, after these 5 days, the platform will still be available. You can still ask for feedback. Maybe the answers won't be as quick, but there certainly will be answers. And we also encourage you to use the feedback form to give us any feedback on the learning material, so we can use your feedback to improve all the material and to make it better for future training events. I would like to, Kostas, do you have some concluding things to say, maybe? We cannot hear you.
Thank you again for organizing the event and for inviting the people. This is supposed to be, this is labeled as a Belgium event, and indeed it was quite successful. What I get from the attendance. And the good thing is that the session has been recorded. We're gonna use your feedback to improve ourselves and to improve our material. And of course, the material will be there, available for free. And we'll be happy to see you to our next events as well. Since unfortunately it will not be physical events, there will be also virtual events. We're going to run the process again. So if you feel that you missed something or you would like to come up with some questions, we will invite you again to our training events around November and then later on in around December. Yeah, that will be all. Thank you for participating. Our trainers are here to assist you with navigating the platform, as we said extensively during the session. And yeah, that will be all. Thank you so much again, Katleen.
Okay, thank you, Kostas. I want to thank all the speakers today, and I want to thank also all the participants. I hope you found it interesting, and I hope you will all access the learning platform and use all the material that's available and spread the word to your colleagues and other people who might be interested in it. So thank you all and goodbye.